Hi, Mr. Professor Denton, Michael Denton. Welcome to our transmission.
I'm pleased to be here.
I really thank you for having accepted my invitation on my YouTube channel. I'm honored about that. And we will discuss today about the intelligent design with one of the most experts in this field. And first of all, I would like to excuse myself for my English, because I will try to translate whatever I have in mind, but my pronunciation is not always perfect. So forgive me about that. I will do my best.
Your English is much better than my Italian.
No, okay. Thank you. So I'm going first of all to read a general curriculum, some information about our expert, about our host, who is one of the most celebrated expert regarding intelligent design. So I'm going to take some information from the Discovery Institute's website. Michael Denton holds an MD from Bristol University, as well as a Ph.D. in biochemistry from King's College in London, a senior fellow at Discovery Institute's Center for Science and Culture. Denton's most prominent book is Evolution, A Theory in Crisis, which dates 1985, and is credited with having inspired both Philip Johnson and Michael Behe to investigate scientific problems with Darwinian evolution. And today we will discuss about Darwinism. His 1998 sequel, Nature's Destiny, How the Laws of Biology Reveal Purpose in the Universe, elaborates on the evidence for design in nature, showing that the laws of the universe and are finely tuned not only for the existence of carbon-based life, but even for complex beings of biology close to modern humans. Dr. Denton's research topic as a PhD student and postdoctoral fellow at King's College in the 1970s was the differentiation of the red blood cell, and we will talk even also about it. And this main research focus since the early 1980s has been on identifying genes responsible for inherited retinal disease in humans. Professor Denton has published his work in journals such as Nature, Biochemical Journal, Nature Genetics, Biosystems, Human Genetics, Clinical Genetics, and the Journal of Theoretical Biology and Philosophy. So, first of all, after this introduction, I will pose you the first question. Some years ago, as we have understood, you wrote that Darwinism is a theory in crisis. Two titles, Evolution, A Theory in Crisis, 1985, and Evolution, Still a Theory in Crisis, 2016. Why can you say that Darwinism is a theory in crisis? If I ask you, what kind of arguments would you exhibit in favor of your thesis?
Okay, well, first of all, a concession. Basically, there's no doubt that natural selection is a powerful organizing force, and it can be responsible for a considerable degree of evolutionary change, as Darwin himself saw when he went to the Galapagos Islands. So certainly natural selection can generate a degree of adaptive evolutionary change. But the problem with the mechanism, the fundamental problem with the mechanism is you can only get something by natural selection if you can get to that particular end, adaptation or structure, in a series of tiny little adaptive steps. In other words, each step has to have some utility, or has to be useful to the organism in which it occurs. And you want to select 1, 2, 3, 4 of these steps to get the particular adaptations. In other words, you've got to go along a sort of a continuum of adaptive change. And of course, immediately you look at the natural world, the biological world, what you find is that there's a great number of adaptations or structures in biological systems which you can't approach in these little tiny steps. I mean, the examples are all around us. There's mammalian hair. There's the mammalian red cell, which we're going to probably touch on later. And then there's things like the extraordinary amniotic egg, which is surrounded by a unique, where the embryo is surrounded by a unique membrane, the amnion. And then you have at the molecular level, you've got extraordinary enzymes like ATP synthase. And you've got, of course, Michael Behe's example of the bacterial flagellum. And you've got, of course, the fundamental genetic code, the underlying sort of coding system, which in fact exists in the genome and in the ribosomes and so forth. So basically, Darwinism works on a small scale. Yes, it works on the Galapagos Islands, and it's really quite silly to try and deny that. Of course it does. But when you come to look at the biological world, it's full of all sorts of complex structures and adaptations for which you can't imagine what the actual sequence of little steps was that led to them. So Darwinism fails because of this basic constraint. And one could go on citing examples which, you know, seem to be beyond the reach of natural selection or beyond the reach of any sort of tiny set of adaptive steps, you know, for a great deal of time. There's a lot there. And there's also another problem as well, of course, because the end, or whatever the end is that you achieve, it has to be adaptive. And when you turn, and this is a sort of a blind spot, I think, in biological science, when you turn to the botanical realm, it's absolutely full of all sorts of patterns of extraordinary complexity. I mean, take a maple leaf, it's a very complex structure, and yet nobody has ever given any explanation of what these particular patterns, what adaptive end they serve. So you've got another problem. Not only can you not get to things in terms of tiny little steps, there's a heck of a lot of order out there, which doesn't seem to serve any specific adaptive purpose. So, you know, basically, as far as I'm concerned, those two arguments are sort of critical, and, you know, you can't get around them. You can't get around them. There's a lot of stuff you can't approach gradually, and there's a lot of stuff which doesn't seem to be even adaptive anyway. Okay.
Thank you. I have in mind in this moment some concepts. For example, irreducible complexity of Michael Behe. You talked about that, and the so-called chicken or egg problem. So you have to have some unity which do work all together. You cannot have a small adaptive changes in order to reach an end. For example, with bacterial flagellum, it's the most celebrated, I think, the most famous example. And then I remember talking about your presentation in Bergamo, which you had some weeks ago. Even the concept of beauty. How can we explain, for example, beauty in Darwinian terms? Beauty we see in nature, beauty we see in leaves, and in other things you showed us. I think it's impossible. Or do you think that even in nature beauty can come following Darwinian paths?
Yeah. Well, of course, no.
I know it's a very strange question. I know.
No, that's okay. No, of course, whether something is beautiful or not has absolutely no particular selective advantage to an organism.
Okay.
So that whole range of phenomena is, you know, outside of the Darwinian explanation, because, you know, Darwinism depends on utility. Things have to have a purpose and a function. Well, whereas beauty might be very edifying for us as observers of nature.
Yes.
The actual thing, that the beautiful object isn't getting any specific advantage from being beautiful. So I think that the whole sort of the thing you're touching on now is, yes, it's part of what you might call the non-adaptive enigma in nature. There's a lot of stuff out there which is non-adaptive, and beautiful things, I think, are not specifically adaptive. Yeah, yeah.
Thank you. So, turning now to your scientific career, what is the most important thing you learned from your empirical research, and what kind of general conclusion did it bring, in your opinion, your research, your scientific research?
Right. Well, basically, I started my scientific career at King's College in London. And I started in the glory days just after the discovery of the double helix. And you may recall that in King's, what is arguably the most important experiment carried out in the history of biological science was Rosalind Franklin's work on X-ray diffraction of the double helix. She showed really that, in fact, the structure of DNA was a double helix. Anyway, so I arrived at King's in after high school, after med school now, actually. Goodness, I'm beginning to get, I'm losing my mind. So I arrived there and I started work on the development of the red blood cell. Now, the red blood cell, that's the mammalian red blood cell. That's the blood cells in you and me. And the development of the cell begins with a stem cell, and the stem cell undergoes a number of cell divisions, which results ultimately in the enucleate red cell. But what's really extraordinary about this process is that the final stage of the maturation of the red cell is the loss of the nucleus. So, the nucleus is extruded from the cell. And the more I thought about this remarkable phenomenon, the more I realized that it's extremely difficult to imagine, once again, going back to these little adaptive steps. I thought it was extremely difficult to imagine what sorts of adaptive steps would have allowed some sort of evolutionary process to eject the cell. I couldn't work it out. It struck me as being completely impossible. And this set me on my sort of skeptical journey. Here I was, the very subject of my PhD thesis, the development of the red cell, involved a profound enigma in terms of Darwinian explanations. You couldn't explain it. So I used to have many, many conversations in the tea room and on the corridors, and King's was quite a prestigious place at the time, and nobody could throw any light on how this could possibly have happened. Okay, so that really set me going. But of course, there were other aspects to this as well. I mean, I came in contact with the fact that the enucleate red cell, we're back to this non-adaptive thing again. The question arose in my mind, not only is it very difficult to explain how the nucleus is ejected from the cell, the final enucleate state is not clearly adaptive, because birds, for instance, which have a much higher demand for oxygen than mammals, they keep their nucleus. So, so there was a final sting in the tail here. Not only could he not explain how the nucleus was ejected from the cell in Darwinian terms, but the final state was not clearly adaptive. Perhaps it is, perhaps it isn't. But it struck me, well, if birds keep it, why do we throw it away? They get by with a nucleus, so and they have a higher demand for oxygen. So that really set me going on my skeptical journey. Yeah.
Thank you. So in 2022, you published The Miracle of Man, The Miracle of Man, the fine-tuning of nature for human existence. Why should man be a miracle? Because, a materialist or a Darwinist would tell you that man is an inevitable product of a very long blinded process of evolution in a very, 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 very old universe. If matter, for example, is eternal or infinite. Or he would tell you that in an infinite number of universes, this is the multiverse theory, the accidental happening of man would certainly be statistically necessary, because in a multiverse, if infinite universes do exist, everything is possible, even intelligent life, even men. What would you answer to a Darwinist or a materialist philosopher or a scientist?
Okay, well, first of all, let's go back and recall what's happened in science over the last 150 years. In both cosmology, in chemistry, in biochemistry, in the study of physiology, what we've actually found is that there is as far as this universe is concerned, and this is what I would like to focus on here. As far as this universe is concerned, it's clear that there is an absolutely stunning degree of fine-tuning which underlies our existence, which enables us to be. And there's two areas where this fine-tuning is very remarkable. The first one is as far as in the chemistry, the key atoms of life, carbon, hydrogen, oxygen, nitrogen, and the liquid of life, which is water. What you find is that these components of the cell possess a stunning, special, unique fitness for the carbon-based cell. In other words, essentially what it means is that in this universe, there was a primal blueprint for the carbon-based cell. Okay, and then when you look at you look, well, what sorts of highly intelligent beings could exist in our universe? And it turns out that, in fact, basically, you've really got to be aerobic. You've got to use oxygen as an energy source, and you've got to burn carbohydrates and oxygen. You've got to be terrestrial, and so forth. There's a whole lot of things you've got to be. And then we find that when we look at the basic parameters, look at the fine-tuning of nature, we find that there's a staggering degree, an equally staggering degree of fine-tuning for beings which share our basic physiological design, air-breathing terrestrial organisms like ourselves. So there's definitely in our universe a primal blueprint for our type of life. And starting from the laws of nature and the order of the universe, throughout the cosmos, there can only be carbon-based life like it exists on Earth, and highly intelligent beings like us, as they exist on Earth, and that will hold throughout the entire universe. So there's so what this actually means, as far as I'll get back to your questions originally, but what this means as far as our universe is concerned, whatever the proximate reasons, whatever the proximate causation was, which led to the cell, the origin of life, or the origin of man in the history of the Earth, it's here by design, okay? Because there was a primal blueprint which specified in exhaustive detail the cell and human biology, if you want to put it like that. So therefore, in fact, whether it's special creation, whether it was Darwinian evolution, whatever it was, in a very deepest sense, we're here by design in this universe. So that's what I mean by the miracle of man, okay? That in this universe, there is a stunningly exacting fine-tuning in all sorts of ways. And it took me the 5 monographs I published to document it all, actually. And I can't even give a summary here, but it's staggering. And so in this universe, in the deepest sense, we're here by design. That is the miracle of man in our universe. Now, of course, I can't prove, of course, that this staggering thing is actually the result of design. And I do agree that in a multiverse or in an infinite number of universes, perhaps there would be one like our universe. But as I'm stressing, my focus is on this universe and what the things are there. And I'm just going to read you something because I'm just going to take a bit of paper off here and have a look at this. I'm just going to get a bit of paper. And I'm not the only person that thinks that the appearance of design is very remarkable. In his book, The Mind of God, Davis, he stated in the last line, the impression of design is overwhelming. Now, these are mainstream guys. They're not NID, but they're out there in the mainstream. And Roger Penrose was equally emphatic. He wrote in a book, The Emperor's New Mind, this tells us how precise the Creator's aim must have been, namely an accuracy to 1 part in 10 to the 10 to the 123rd. Now, this is Roger Penrose. He's arguably one of the leading theoretical physicists of today. He was, of course, Stephen Hawking's collaborator for many years. Okay, this is an extraordinary figure. One could not possibly even write the number down in full in the ordinary dentary notation. It would be 1 followed by 10 to the 123 successive zeros. Even if we were to write a 0 on each separate proton and each separate neutron in the entire universe, we could throw in all the other particles for good measure, we should fall far short of writing down the figure needed. Roger Penrose, The Emperor's New Mind. So these guys are not ideas, right? They're mainstream science. And they're saying that the impression of design in our universe is absolutely overwhelming. So one thing I would say, even if I can't prove the design, and even if I do concede that if there is a multiverse, which of course is more of a logical possibility rather than an empirical fact. I mean, nobody knows whether it exists or not. Okay, but all I can say is that it's not just ideas that infer design. There's many mainstreamers out there who feel the same, and this all goes back to Hoyle, who made the first sort of anthropic prediction when he said that in fact the resonances of beryllium, carbon, and oxygen have to be just what they are to ensure that carbon and oxygen are synthesized in the universe, and also the higher elements as well. So basically, I think that the atheists and materialists out there who oppose theism have to face a difficult question. They can say, well, ideas are empowered or influenced by religious belief, but I don't think you can start including Davis, Penrose, Hoyle, and everybody else that's biased in their seeing an overwhelming evidence of design in terms of religious belief. So basically, ID in that sense, the fundamental claim of ID, especially if it's based on an examination of fitness, which is my particular focus, is actually fully mainstream. It's rational and sensible, and it's the only basically sensible interpretation you can make. Okay, so I'm talking too much as usual.
No, it's perfect, because I wrote here a note, and I don't know if you do agree. I've written it here 1 minute ago. So in one sense, we could say, and just tell me if you do agree with that, then that we cannot give a mathematical certainty, a mathematical evidence about ID, but in a sense, we can work with the certainty of natural laws. We can have rational arguments taken from the scientific field about the ID. So rational arguments, not mathematical ones, of course, because this is not mathematics. What do you think about that?
I think we're kindred spirits. I mean, I entirely agree with what you've said. Okay. Yeah. I mean, I think you simply can't give a mathematical proof.
Okay. Perfect.
That's it.
Perfect.
But in terms of common sense, rationality, the way we approach the universe, the way we understand things, then the impression of design is overwhelming. Yeah.
So
100% with you.
Next question. How did the academic community react to your research? This is a very bad one. A very bad one.
It was a witch hunt. They were up in arms. It was a real witch hunt.
Okay.
Shortly after Evolution, the Theory of Crisis was published, I was working as a clinician at the Prince of Wales Hospital in Sydney, and immediately the academics at the University of New South Wales called me down to give a talk to justify my heresy.
Okay.
And so so I was given a very rough ride, believe me. And so, but basically it's strange. It wasn't just the most mainstream biologists didn't like Evolution, the Theory in Crisis, and they didn't like me. However, there was one group of biologists at the time who were what is now termed, I think, radical cladists. They were people involved in taxonomy and classification. In the Natural History Museum in South Kensington in London, and in the American Natural History Museum of Central Park. And these people, radical cladists, had a system of approaching classification which depended on identifying unique defining features of particular groups. And so each clad, had defining features, and they were defining in the sense that they weren't led up to. So we're back to what we were talking about at the beginning of this interview. Darwinism can't abide discontinuity or saltations or jumps, and yet the whole of the cladistic approach to classification depends on identifying clads by their common possession of unique properties which are not led up to. Okay, so in fact, and of course, there was a major chapter in Evolution Theory in Crisis about cladism and about classification, and with an emphasis on cladism and the way that cladism works. And because of this, it's quite amazing. There was two top biologists at the American Museum of Natural History. There was Gareth Nelson and Norman Platink. And they were both radical cladists, and they were involved in classifying invertebrates. Okay, they asked me to visit them in the American Museum of Natural History, and sort of incredible. These are two top academics in the US. Sort of endorsed some of the fundamental arguments in evolutionary theory in crisis, which was amazing. And so I went there and had an afternoon's discussion with them. And they affirmed that the basic principles of cladistic classification do threaten, orthodox Darwinian biology, because of the fact that clads have specific defining characteristics which are not led up to. So that was nice. But on the whole, the book was greeted with in many biological academic circles, it was considered heresy and things, and I was given a pretty rough ride all over the place, but it was not universal, as I say. There was little pockets within academia which would probably not publicly endorse the book, but privately thought, yes, some of Denton's arguments are okay. No, is there anything else? No, I think that's. I've got nothing a great deal more to say about that. Yeah.
So I would like to ask you what is the subject matter of your research now? What are you working about now?
Well, from the 80s right away through till only about 10 years ago, I was working actively on research into retinal genetics. I was looking for genes that cause retinal disease. And I was mainly collecting families in India and sending them to NIH or to Moorfields in London, and also some, I think, to a lab in Hamburg in Germany. But that research now is sort of fading away. I'm still in contact with my colleagues in India, and I'm still occasionally visiting India and occasionally seeing patients. But essentially, I'm retired from that major sort of work, which was, for 20 to 30 years of my life was a major research focus on retinal genetics. So I'm really retiring from that now. At the moment, my major interest is fitness, is the fine tuning of nature for life as we see it on Earth, and that was the focus of the monographs, and it's still it's still a major interest of mine, and I keep on finding new elements of fitness. The more you look at fitness, the more you find. I mean, just to give you an example, I wrote Miracle of the Cell, and I knew about the electronegativities of the four key atoms: carbon, hydrogen, oxygen, and nitrogen. But I hadn't realized that oxygen and nitrogen, along with fluorine, are the only three atoms in the periodic table of elements which give you hydrogen bonds. And that's, of course, a crucial property. And that's why, in fact, you have to have oxygen and nitrogen in organic compounds, right? Because you need the hydrogen bond. It plays such a vital role in ordering the higher macromolecular order in the cell. So, and I found that reading recently, Linus Pauling's great classic, The Chemical Bond. In chapter 12, he mentioned the hydrogen bond and its importance in biochemical systems. And so that was the more you look, the more you seem to find things. And that's an extraordinary thing. The reason why fluorine has to be excluded is that fluorine binds with carbon, making what you call forever chemicals, right? And so you've got to exclude fluorine from the organic realm because it forms forever chemicals, poisonous chemicals with carbon. So you need oxygen and nitrogen, and that's a critical reason why they are included in the organic realm, in biological systems. Yeah, the hydrogen bond, beautiful. So, you keep on finding different things, yeah, and more depths of fitness the more you look. It's extraordinary. Yeah.
Yes, I think so. I do agree with you. So I have a last question. Last question is the following one. Some days ago in Bergamo, we talked about the future of scientific research. And you told me you believe that in the next future, a very important revolution in favor of the ID will take place in science. Can you tell us why do you believe that?
Okay. Well, there's a number of things. The first thing is that the actual ID movement itself is, I've been connected with it for 40 years. And basically, it's expanded relentlessly every year. And at the moment, there's many more researchers. And these are people with PhDs, and these are people in science who are supportive of the ID movement, the idea that, in fact, life can only be explained in terms of some form of intelligent design. So that the movement itself has grown enormously. And at the moment, many people, many ideas are publishing papers in the mainstream journals. So, on things like the waiting time and areas like this. So basically, the first part of the answer is that the ID movement has grown relentlessly over the last 40 years. And if this growth continues, and I think it will continue, because I think the arguments are solid and very difficult to refute in terms of, the general ID approach, I see the movement growing and growing and growing. And there's every possibility. You must remember that in the past, ID was mainstream. Most scientists from from Copernicus, from the Copernican revolution all the way down, Kepler, Newton, right away until the Darwinian revolution and the beginnings of the modern atheistic materialistic phase, right? It was mainstream. And the idea that it can't be mainstream again is of course just simply insane. What could be mainstream for centuries of science could become mainstream again. And so basically, given the growth of the ID movement, and given the weakness ultimately of Darwinian explanations, the strength and mainstream nature of ID type arguments based on fitness, then I see every possibility that this movement, it may not completely capture the mainstream in the next few decades, but certainly I think it's going to become a more and more important intellectual movement right across the board. Okay. Now, as far as developments are concerned as well, let's take the origin of life. I've been watching the origin of life field the whole of my academic life. And after decades of claiming it's going to be explained, 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 we're no further forward. Nobody has any clear idea how living things arose. But we've already mentioned earlier in this talk that there's a primal blueprint for the cell. So we know that in some sense it arose by design. Okay. Now let's see what happens about the proximate causes. Although the exact sequence of events which led from chemistry to the cell on Earth are not understood, we do know that in the end it's clearly it's clearly in some sense there by design, because the prescription was already written into the laws of nature from the beginning. Now there's two things that might happen. Either nobody will ever find that sequence of events. They'll never find a natural explanation for that sequence of events. So you've got the design, and you've got some huge enigma in going from chemistry to the cell, still, despite the design. And one explanation there clearly is something like special creation. So it's another miracle, like the origin of the universe. Okay. The other possibility is that we might find a set of new laws of nature, which give every impression of having been ordered and embedded in the fabric of things to cause that transition. But in both cases, it's pointing to design. Whether it's special creation or whether it's some remarkable upfront fitness in nature which draws life from chemistry. Okay, so this problem is coming. I think it's coming like there's no way you're going to escape this. My prediction is that it's never going to be explained in terms of current laws of nature. So either it's something utterly miraculous, or there's a huge amount to be discovered which will explain how this happened. And this will be within the design sort of framework anyway. So that's one thing. So therefore, the conventional atheistic sort of materialist thing it could face a huge challenge in the origin of life area. Sorry, I hope I'm not repeating myself too much. Okay, yeah, okay. But there's another area as well where I think that in fact the ID sort of framework and worldview is going to be supported, and that's in the study of the mind. I mean, at this moment in time, an immense effort is being made from using all sorts of fantastically sophisticated technologies and approaches to try and show how mind is some sort of epiphenomenal, which comes from matter, that mind is somehow something to do with matter, comes from matter. My feeling is this will fail, and that mind as something, consciousness, the subjective area of the world, will never be reduced to the properties of matter. In other words, basically the ancient pre-Socratic conception that all there is atoms in the void, that's all there is going to face some sort of crisis. And the irreducibility of mind, which I'm predicting, does mean that in fact the idea of a transcendent mind behind the universe, can't be dismissed. I'm not saying anything stronger than that, but it can't be dismissed. But if you look at this, if you look at the growth of the ID movement, the attractiveness of increasing attractiveness of design to more and more people in the intellectual sort of area, and you look at the impossibility of accounting for the origin of life in terms of sort of non-design hypothesis, if you want to put it like that, and then the probable irreducibility of mind. These three sort of areas seem to me to raise a very definite possibility, even probability, that we will see in terms of Western civilization, scientific culture, will find design hypothesis, far more attractive than has been the case over the last century.
Thank you, Professor Denton. I very appreciate your time, for your dedication of your time to our interview. I really thank you, and I hope to have you again on this channel in the next future, if possible, talking about posing other questions or other argument. And is there something you would like to add to our interview as a final conclusion?
No, I really enjoyed the interview. I was a bit, I always have stage fright, and but basically, I think it was okay. I think I lost my concentration once or twice, but nonetheless, not very many times. No, yeah, and I'm be very happy to do something else. I mean, we could do a specific one on the anthropocentric conception of nature, which was, of course, the medieval view. And it's my view is that what happened was at the beginning of the scientific revolution, there really was no evidence to support that idea. But as we said in this talk earlier, over the last 150 years, gradually more and more evidence has come to light, which supports the notion that we humans do occupy, a special place in the natural order. I mean, that was implicit in much of the discussion earlier on, but nonetheless, I think, in fact, you can. I'd be quite delighted to do a interview about the recovery of the anthropocentric conception of the nature of the world. And that's terribly important for Christian viewers too, because the doctrine of the incarnation means that, to me, I'm not that religious myself, but looking logically at that Christian doctrine, that does imply that we humans, whatever faults and things we may have, do occupy some special place in the order of things from the beginning. And another thing which I haven't brought out in this thing is that the study of fitness, unlike the study of complex adaptations, I mean, you can take, for instance, the bacterial flagellum or ATP synthase. You can take amazing molecular machines, but that can't tell you the intention of God with creation. But the cosmic fine-tuning and the fine-tuning of the properties of water and the atoms for life, and then for our physiology, was there from the very beginning of creation. This order was in the fabric of things from the beginning, which in a sense, and this idea only came to me very shortly, and I'm just about to send a proposition to make some videos with a guy at in Seattle, in the ID, is that from fitness you can read, and in a sense, the mind of God, or God's intention with creation. You can see the plan of creation in the fitness, because it's so specific and exacting, and it's a set of primal blueprints. But you can look at all other aspects of the world out there, and you can't see that evidence. That evidence resides in fitness, and probably in no other area of knowledge. So that's greatly interesting me now, because I realize that it's I mean, Davis wrote a book, The Mind of God, which is talking about cosmological constants, and that's along the same lines. But if you move it right into biochemistry and human physiology, it's extraordinary. And then you can see, well, the doctrine of the incarnation, whether it's right or not, it makes sense in terms of the intention of God for creation was man. You see.
I would be very, very, very happy to talk with you in the future about the recovery of the anthropocentric view. I think it would be even very interesting from a philosophical and theological point of view, even theological and philosophical.
Well, I'm delighted to do another one of these interviews. Where if you want another one later on, that's fine by me.
Thank you.
It's been a pleasure doing this one, and it's God, it's taken quite a time.
No, it's just 45 minutes. 45
minutes.
45.
Perfect.
Yeah, it's okay for an interview. I think it's okay. It's okay. So thank you again, Professor Denton, and have a nice day.
You too. It was a pleasure. And see you again sometime. Yeah.
See you again.